Every breath taken by 3 million people in Naples, Italy, now contains carbon dioxide levels that should not exist outside volcanic craters. This is not speculation or future projection. It is the measurable reality of 2025, when atmospheric monitoring revealed that Campi Flegrei supervolcano has converted the air above Italy's third largest metropolitan area into a chemical weapon targeting human respiratory systems. The numbers tell a story of systematic atmospheric poisoning that defies every assumption about volcanic safety. Campi Flegrei now releases 5,000 tons of carbon dioxide every day, creating air concentrations of 572 parts per million across Naples, 33% higher than global atmospheric background. For context, this supervolcano produces 7 times more carbon dioxide than Mount Vesuvius, while sitting directly beneath one of Europe's most populated urban centres. What transforms this emission crisis into a metropolitan siege is the deliberate precision of its atmospheric distribution. Mediterranean sea breezes carry Campi Flegrei's carbon dioxide plume directly toward Naples' western neighbourhoods, where it settles into low-lying areas, accumulates in underground spaces, and infiltrates the breathing zones of hundreds of thousands of families. The volcanic system operates like a chemical warfare deployment designed for maximum civilian exposure. Emergency inspections throughout Naples have revealed the true scope of this atmospheric siege. Underground facilities across the metropolitan area now register carbon dioxide concentrations approaching 6,000 parts per million, levels that can cause loss of consciousness and potentially death in enclosed spaces. Fire department teams have identified carbon dioxide accumulations in shopping centres, parking garages, subway systems, and residential basements, creating an invisible network of potential death traps. The source of this chemical siege reveals Campi Flegrei's evolution into something unprecedented in volcanic history: a supervolcano that wages chemical war against civilian populations. Scientists confirm that 40% of the carbon dioxide emissions result from the hydrothermal system converting limestone bedrock into gas, meaning this volcanic monster is consuming the geological foundation beneath Naples to fuel its atmospheric attack against 3 million residents. But the most terrifying question remains unanswered. When a supervolcano launches a chemical siege against metropolitan populations, using the atmosphere itself as a weapon delivery system, how does civilian evacuation even function? What defense exists against a volcanic threat that turns breathing into the primary danger? And why is this chemical warfare accelerating precisely as Campi Flegrei approaches its most unstable phase in centuries? To understand the crisis unfolding beneath Naples, we must journey into the geological architecture of one of Earth's most dangerous volcanic systems. Campi Flegrei is no ordinary volcano. It is a massive 12-kilometre wide caldera, a crater-like depression formed by the catastrophic collapse of a magma chamber during a supervolcanic eruption 39,000 years ago. This ancient cataclysm, the Campanian ignimbrite eruption, blanketed the Mediterranean region in volcanic ash and created the nested caldera complex that now underlies the western outskirts of Naples. The true danger lies in what this eruption left behind: an active magmatic system capable of erupting with a force that dwarfs anything in recorded human history. The caldera itself is a labyrinth of volcanic hazards. Multiple eruptive centres dot its surface, each representing a potential pathway for magma to reach the surface. The Solfatara crater, a hissing landscape of mud pools and fumaroles, serves as a window into the seething hydrothermal system below. Just to the east, the Pisciarelli fumarolic field marks the intersection of volcanic gases rising through a network of faults and fractures. Even the spaces between these eruptive vents pose a hazard. Vast areas of the caldera floor exhale carbon dioxide, through a process called diffuse degassing, releasing hundreds of tons of gas each day through the soil itself. Completing this geological mosaic are a scattering of hot springs and bubbling mud pools, each one a testament to the restless volcanic forces stirring beneath the surface. What makes Campi Flegrei uniquely dangerous is not just the presence of volcanic features, it is their proximity to human life on a massive scale. Dr. Giuseppe Velardo, a geologist at the Vesuvius Observatory, explains that Campi Flegrei represents Europe's most densely populated active volcanic system. Unlike isolated volcanic centres, this caldera integrates with urban infrastructure, making atmospheric emissions a direct public health concern rather than a remote geological phenomenon. In other words, the geological forces that drive Campi Flegrei's volcanic activity are now intertwined with the daily lives of millions. Every fluctuation in the caldera's behaviour, every change in its emission patterns, reverberates through the streets and buildings of one of Europe's largest metropolitan areas. It is this entanglement of geological and human systems that has transformed a routine volcanic process into an atmospheric siege. At the heart of Campi Flegrei's atmospheric crisis lies an invisible killer, carbon dioxide. This odourless, colourless gas is often overshadowed by more visually dramatic volcanic hazards like lava flows and ash clouds, but in Campi Flegrei's case, it represents the primary threat to human life. The caldera's carbon dioxide emissions come from two primary sources. The first is the magma itself, which releases huge quantities of dissolved gases as it rises through the crust. These magmatic emissions account for 60 to 80% of the total carbon dioxide output, representing the direct exhalations of the volcano's molten heart. But it is the second source that truly sets Campi Flegrei apart. Another 20 to 40% of the carbon dioxide comes from a process called hydrothermal decarbonation. Essentially, the volcanic system is baking carbon dioxide out of the limestone bedrock that surrounds the magma chamber. As hot fluids circulate through the crust, they react with the calcium carbonate in the limestone, releasing carbon dioxide in a self-reinforcing cycle that can continue for centuries. The result is a multi-pronged degassing system that operates across a staggering range of scales. Carbon dioxide escapes from the caldera through fumarolic vents, bubbling mud pools, and even diffuse soil emissions, creating a mosaic of gas sources that span the entire caldera floor. During peak activity, this system can release 3,000 to 5,000 tons of carbon dioxide per day, levels comparable to the emissions of a mid-sized coal-fired power plant. What makes these emissions so dangerous is the ruthless efficiency of their atmospheric distribution. Dr. Alessandro Aiupa, a volcanologist at the University of Palermo, explains that carbon dioxide from Campi Flegrei follows predictable meteorological patterns. Mediterranean sea breezes create systematic transport toward the western districts of Naples, making atmospheric contamination a recurring public safety concern during high emission periods. In other words, the local wind patterns act like a conveyor belt, carrying Campi Flegrei's carbon dioxide emissions directly into the heart of Naples. The gas settles into low-lying areas, accumulates in underground spaces, and infiltrates the breathing zones of the city's most densely populated neighbourhoods. It is a form of atmospheric poisoning that unfolds in slow motion, turning the very air into a vehicle for volcanic toxicity. To the casual observer, Campi Flegrei's current crisis may seem like a sudden and unprecedented event. But volcanologists have been tracking warning signs for decades, watching the caldera's behaviour evolve through a series of increasingly intense unrest periods known as bradyseismic crises. Bradyseism refers to the gradual ground deformation that often accompanies volcanic unrest. In Campi Flegrei's case, these slow movements of the Earth's surface serve as a barometer for the volcanic pressure building underneath. And over the past 70 years, that barometer has been sounding an increasingly urgent alarm. The first major Brady-seismic crisis of the modern era struck in 1950, when the port town of Pozzuoli saw its streets and buildings rise by a staggering 1.8 meters over the course of 2 years. This period of rapid ground uplift was accompanied by thousands of small earthquakes and forced the evacuation of 8,000 residents due to structural damage. The pattern repeated in 1970 and again in 1982, each time with greater intensity. From 1982 to 1984, the crisis saw ground deformation rates reach their highest levels ever recorded, with parts of Pozzuoli rising by 1.8 meters in just 2 years. The town became a seismic war zone, rattled by over 16,000 earthquakes that damaged hundreds of buildings and forced the evacuation of 40,000 residents. These Brady seismic crises were not just isolated geological events. They were dress rehearsals for the atmospheric crisis that would engulf Naples decades later. Each period of ground uplift was accompanied by a surge in carbon dioxide emissions, with fumarolic temperatures and gas compositions shifting in lockstep with the caldera's heaving and shuddering. Dr. Claudia Troise, a geophysicist at the Vesuvius Observatory, explains that the crisis from 1982 to 1984 established Campi Flegrei as a modern volcanic emergency requiring permanent monitoring. For the first time, European authorities confronted the reality of managing volcanic unrest affecting hundreds of thousands of urban residents. But even as the Brady seismic crises of the 20th century faded into memory, Campi Flegrei was preparing for an evolutionary leap. The cycles of uplift and subsidence, the surges of seismic activity and gas emissions, these were just the opening acts in a volcanic drama building toward a catastrophic climax. The current crisis at Campi Flegrei began not with a bang, but with a whisper. In November 2005, after 2 decades of relative quiescence, the caldera's coastal regions once again began to rise. The ground uplift was subtle at first, just a few centimeters per year, but it marked the beginning of a new chapter in Campi Flegrei's restless history. Over the next decade, the signs of unrest grew increasingly ominous. By 2015, the total ground deformation had reached 42 centimeters, and the fumarolic fields at Solfatara and Pisciarelli were roaring back to life. Gas emission temperatures soared to record highs, while the caldera's seismic activity intensified from a background murmur to a persistent rumble. But it was the carbon dioxide emissions that truly set alarm bells ringing. Between 2005 and 2020, the daily carbon dioxide output from the caldera nearly tripled, rising from a baseline of 800 to 1,200 tons per day to a staggering 3,000 to 5,000 tons per day. Suddenly, Campi Flegrei was exhaling more carbon dioxide than many actively erupting volcanoes, and it was doing so directly beneath one of Europe's most densely populated metropolitan areas. The volcanologists tasked with monitoring this unfolding crisis could see the warning signs written in every stream of data. Dr. Giovanni Chiodini, a geochemist at the Vesuvius Observatory, says the 2005 to 2020 period represented systematic volcanic awakening with all classical unrest indicators. Unlike previous Brady seismic episodes lasting 2 to 4 years, this crisis has sustained escalating activity for 2 decades, suggesting fundamental changes in the underlying magmatic system. Those changes reached a terrifying crescendo in the early months of 2025. In January, earthquake swarms rattled the caldera with a fury not seen since 1982, their staccato bursts of activity punctuated by ominous underground rumblings. By February, the fumarolic fields were belching carbon dioxide at unprecedented rates, their emissions swamping monitoring stations and infiltrating the homes and businesses of Naples residents. The atmospheric siege had begun, and it was just the opening salvo in a war that would pit an ancient supervolcano against the heart of modern Italy. Campi Flegrei had declared its presence, and millions of lives now hung in the balance. Campi Flegrei's chemical siege has begun, turning the very air above Naples into a weapon against 3 million residents. When a supervolcano weaponizes the atmosphere against the largest urban population ever threatened by volcanic chemical warfare, how long before breathing becomes impossible across Europe's most densely populated volcanic region? Subscribe to Earth Attacks for real-time updates on Campi Flegrei's accelerating atmospheric crisis and the chemical siege that could reshape Mediterranean civilization forever.